The Inkspot platform is a collaborative environment for research and development. It can be deployed in different cloud environments, such as Amazon EC2, Windows Azure, or in an organization's private cloud. Here we will see Inkspot Science, which is one application of the Inkspot platform, specifically designed for data analysis. This demonstration will show uploading and analyzing data using a combination of code written in Java and Octave. We will show how to deploy code into the Inkspot platform and integrate it into a workflow. Finally, we will show how to build an application that leverages the power of the Inkspot platform via a REST-based API. Inkspot securely hosts files and documents. For this demonstration, we will upload a new document that will then be processed using a workflow. All files within Inkspot are versioned, and here you can see the first version that we've just uploaded. Viewing the contents of the file, we can see that it's some data in CSV form. All files within Inkspot are secure and initially only visible to the user who uploads them. However, they can also be made completely public if the user wishes, or access can be given to selected individuals or groups with whom that user is connected. We will now demonstrate creating a workflow that will take the data we have just uploaded and build a neural network model of it. Firstly, we must load and parse the data, then we will scale it to normalize the values. The format of the data means that we must remove the last column, which contains the values we are trying to predict, and then we can connect it to a block which will build the model. Once the model has been built, we join the predicted values from the model to the actual values from the dataset. Finally, we will plot a graph of the predicted values versus the actual values. With the structure of the workflow complete, we must set some properties, selecting the file that we've just uploaded to be used as input, and selecting the column of data that contains the actual values. When we click Execute, the workflow will be scheduled to run in the Inkspot cloud. When it has completed, we can see the status of each block, with green ticks indicating success. We can also view the output of the workflow, in this case the graph, which is subject to the same versioning and security constraints as any other object within Inkspot. Blocks themselves are versioned, and should we wish, we can pick a particular version, or alternatively choose always to use the latest version. This allows for data analysis to be repeated precisely. We will now show how to create a new workflow block using the Octave language, which is an open source version of MATLAB. Blocks can be created in either Octave, Java, or R. To create a new block, we use Apache Maven to create a template project and fill in some standard parameters. The block we will create here will implement the partial least squares algorithm. With a template block produced, we can open it in our preferred IDE, in this case IntelliJ. business logic of the block is placed in the main.m file. We define the interface in a file called service.xml. In here we define some properties for the block, such as the number of latent variables to use. We also define and name the input and output parameters. We paste the required MATLAB libraries into the script directory. With the implementation of the block complete, we can run a Maven command to package and upload the block into Inkspot. When we return to the Inkspot web application, we can see that the block we created has been added to the block palette, and we can then add it to the workflow. Adding blocks is very easy. Simply drag the required block from the palette on the left-hand side of the screen to the drawing on the right. Clicking on the block gives a menu with options to set the properties of the block, choose a specific version, or view help information. Here we join the output of the model with the actual values again and plot another graph. When we run the workflow again, we can see that two graphs are now created, one for each of the models that's being built. We will now develop a web application that uses Inkspot via the API. Again, we will use Apache Maven to create a sample project. The sample project comes with code to allow a user to log on, and then provides a list of that user's files. In order to deploy the sample project on the JBoss application server, we add a simple deployment descriptor which specifies the context route of the web application. We also configure the Inkspot client library by adding the URL of the server, an ID, and a key for the application. These are all provided by Inkspot when the application is registered. We can then build the application and deploy it to JBoss. When we visit the website, we can sign in, and we're then presented with a list of our files. Whilst code is provided in the sample application in order to list a user's files, we can extend it to execute the workflow that we have just created. This demonstration shows the process speeded up, but it would usually take only 10 minutes or so. A video showing the process at normal speed is also available. The new application will have 4 additional pages. One will choose a file to be processed. One will choose the workflow, and another will start the workflow running. Finally, one will show the state of the running workflow. When the workflow is complete, this page will also display any results generated. Once we redeploy the application, we can sign in again, and this time the files are now links to the next stage of the process. We will choose the same file, thursday.csv, Then we will choose the same workflow. When we select the workflow, it will be scheduled to run on the Inkspot cloud as before. We can see the status change from waiting to running. When it's complete, the two graphs are displayed. The differences between the two graphs can be seen in the large trough on each one, with the first model generating better predictions. Inkspot's current status is a stable open beta, in regular use by over 200 people. We have mainly focused on R&D, and Inkspot currently contains many libraries for science and engineering, as well as generic blocks for data analysis. For further information, please email info@inkspot.co.